Good evening, everyone. Welcome to Unacademy. Welcome to the session. This is your Shankar sir here. So let me start the session of Learn Digital in 20 hours. Today is the lecture 4. So we are going to discuss digital circuits, combinational circuits today. So let's start the session. Before that, past 3 days, as I have announced already, we have taken a short break, and today onwards we are resuming this class. And every single day we will continue almost like 2 hours every day. So today I am going to finish the content part, that is the theory part of combinational circuits. Mostly the theory will be done today, and few problems we will be doing today, and more number of problems. Tomorrow is the session for entirely problems only. That is combinational circuits, total problems revision will be happening tomorrow. So this is what's happening in the today and tomorrow session. Today's session I may not be able to reply you in the live because of the limited strength. I'm playing the live where I cannot give you the reply in this case, and I will not be able to see your chart in the today's session. Okay, so let's continue the session. So अभी तो अकेडमी पे ऑफर चल रहा है भाई. So if you want to take, right, if you want to take subscription, use my code Shankar10. You can save the price up to 36% because they will also provide you discount of 2 months, and also they are providing you the what we call extra 2 months for free, and some price drop is also there. So for 1 year subscription, all you need to pay is around 31,412. After all the discounts, you will be saving this much. So around 36% you can save by using this uh, what we call offer that is going to end tomorrow. And I hope you know these are our toppers this year from Unacademy for GATE ESE 2022. And I hope you people knows that tomorrow the new batch is going to start for signals and systems. That is going to happen at 7 a.m. and digital also going to start at 5 a.m. So signals and system I am going to start for plus subscribers. 24 and 25 aspirant के लिए बैच शुरू हो रहे हैं. So आप लोग सब्सक्रिप्शन लेना चाहे तो you can take the subscription and start your journey. एंड इसमें बहुत सारे एडवांटेजेस है आपको. इस पर्टिकुलर बैच में सारे पीएसयूज कवर हो पाएगा. पीएसयू का इंटरव्यू प्रिपरेशन, सारे टॉप क्लासेस बाय द टॉप एजुकेटर्स ऑफ द कंट्री यू विल बी गेटिंग इट. एंड you can access the live as well as recorded of the past 2 year classes without any difficulty. So all the digital notes will be available, live test series is available. So unlimited practice you can have. All these features you can get with the Unacademy Plus subscription. So this is our batch, and the subject we are going to start is signals and systems. Okay, so signals and systems is going to start tomorrow. Around 36% you can save by using this code Shankar10 if you want to take the subscription for K24 and 25, because this is a very good subject to start your journey of the GATE examination. Okay, chalo. So this is for IRMS preparation. This is our team for IRMS preparation. Okay. These are the exams going to happen AMT. I hope you know 2 more exams are left over. Please enroll to this using the code Shankar10. The link of this video, it is available, the AMT examination. Please check your performance. Right. So let's start with the combinational circuits as usual. We are done with the arithmetic circuits. Now we are discussing the switching circuit. Last lecture I have explained already the multiplexer concept. Right, multiplexer में few questions भी किया. We will do few more questions definitely, but let's complete with the theory of the demux, decoder, encoder, everything today. So my wish to complete the entire digital combinational circuits today itself. Okay, chalo. So I have given already the basics of addition, subtraction, ये सभी चीज तो last classes में discuss किया. Arithmetic circuits हो गया, carry, dagger, etc. Then we have discussed about the mux in the last lecture. how mux acts as a universal gate, how to implement the functions using the mux. All these things we have discussed in the last lecture. Okay, so the question here, how many determine the number of multiplexers required to implement what we call uh, full adder. This is the question for today now. So please, here the point is, if you want to implement any three variable function using 8 by 1 mux, you just copy the truth table output at the input of the mux. So what are the number of muxes required? So please try to answer this. I am giving you sufficient time for this. How many mux required? What happened? The screen is blurred. Just a moment. Yeah, time up. So to implement a full adder using 8 by 1 mux, see, it contains two functions, sum and carry. Sum is the sum of the minterms 1 to 47. Carry is sum of the minterms 3, 5, 6, 7. Okay, so it is very simple. You take one 8 by 1 mux for the inputs 1 to 47. For input 1 to 47, you make the input value for that particular minterms as 1. Remaining inputs you make it as 0. You can implement the sum. So take 8 by 1 mux. So sum of the minterms 1, 2, 4, 7. इसको 1 देके बाकी को 0 दिया तो it will implement your required function. That is sum. But for carry, one mux can implement only one function. Adder contains two functions. What are they? Sum and carry. So carry के लिए you require one more multiplexer. ABC are the selection inputs. Sum of the minterms 3, 5, 6, 7. बस हो गया काम. So it requires two mux. Okay. Next question. To implement the function, just I need to implement a 4 variable function using what? 8 by 1 and also 4 by 1. 4 by 1 I have explained yesterday. Now how to make it using 8 by 1, let us see. Take the selection lines as ABC. D can be 0 or 1. So start with all zeros. Okay. So here, this box 0, 0, 0, 0 is 0. 1, 2, 3, 0, 0, 1, 0, 0, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15. Now sum of the minterms 0, 1, 4, 5, 7, 9, 10, 12, 15. Okay, this is D bar input and D. Okay, so now let us see what we call what are the inputs you should apply. And both are selected 0. nothing selected 1. Both are selected 1. Here reverse. Both are selected 1, nothing is selected 0. Bottom is selected D. Top one is selected, D bar is the input. So you should take 8 by 1. 1 0 1 D D D bar D bar D. That's a function. Okay, so this is how you can implement the 4 variable function using 8 by 1 mux. Last lecture we have already discussed how to implement a 4 variable function using a 4 by 1 mux. This is already done using 4 by 1 mux. Okay, this is done in the last lecture itself. Last lecture, last problem I feel. So if don't cares are given, how to deal it means if don't cares are required, I mean don't cares may it is not like a K-map. Don't cares here implementation point of view, internal structure is already fixed. Only external you are connecting these gates now. If don't care is helpful to minimize this, we may use the don't care. Otherwise we neglect the don't care. Same as in the K-map, but small change. Suppose take this function A, B, C. C bar and C 0 0 0 1 1 0 1 1. A B C na 0 1 2 3 4 5 6 7. So sum of the minterms 2 5 don't cares 1 3 4 6. Here if see here the problem here if you don't worry about the don't care, if you don't consider the don't care, answer is 0. If you consider the don't care, it is a C. Which one is okay for you? Anything is fine. So we just neglect the don't care here. Here if you consider the don't care, you get C bar plus C 1, we take it. If you neglect the don't care, C bar inverter is required. Instead of that, better to directly consider the don't care and eliminate the inverter. If by chance any of the other function is, if this is like this, suppose if 4 is the midterm, 5 is not a don't care, then C bar may come, then you need not worry about it because already inverter comes means we use the same. But here possibility check karo. Here even you take don't care also no problem. Logically C also okay because it is a don't care. But technically we always try to avoid the don't care, means we always by chance if that occurs also it should give 0 is more acceptable compared to giving unnecessary ones. Anyway, that is fine. Now see here. What I want to say here is if you consider this don't care, you get 1. Neglect the don't care, you get C. So I neglected, I don't consider. But here compulsory, I should consider. Otherwise, it will give you C bar. Here, if you consider the don't care, you get C bar. Instead of that, leave it, get 0. Because I don't want to waste or I don't want to keep extra inverter. That is to be, the extra logic gates to be eliminated. 0, 1, C. This is how to deal with the don't care. If examiner give you product of sums, first convert it into sum of products and you can do it. These things we have done in the last lecture. Now let's do this question. This is the question given in 2021 I feel. Same model 3 times appeared in your examination. So better to do it. Give a try. Please give a try. Okay, I'll give you time. Just tell me the answer. What's happening? 1 minute time I'm giving you. 5 seconds. And that. So for the circuit shown in the figure, the delay of the NOR gates, multiplexers and inverters are 2 nanoseconds. So NOR gate 2 nanosecond, multiplexer 2 nanosecond, inverter also 2 nanoseconds. Okay. Oh, no. Are 2 nanoseconds, 1.5 and 1 nanoseconds. The delay of the NOR gates, mux and inverter. NOR gate का 2 nanoseconds, mux का 1.5, inverter का 1 nanosecond. Okay. Now, okay, leave it. So first here, because it is a mux circuit, don't blindly add to 1.5 to 1.5, 3.5 plus 3.57 is the answers are nicer. Because it is a multiplexer circuit, switching circuit, at a time only one input will be selected. Either first one or bottom one will be selected, not both of them. So we should understand if the selection input is 0, what happens? Selection input is 1, what happens? You should take both of them and calculate the delays, and whichever gives you the more delay, that is to be considered as your answer. So first case here, if t equal to 0, inverter requires how much time? 1 nanosecond. It will become 1. At what time? T equal to 1 nanosecond. Leave it. So when t equal to 0, this will be the path, right? So 2 nanoseconds. Assume all inputs are applied at the same time. At time t equal to 0. So 2 nanosecond plus 1.5, you get the output at 3.5 nanosecond. Now, because the selection input is 1, it will select this. But this will be selected at 1 nanosecond. But input is not ready now. Input, it should wait for 3.5 because two of them are coming. Whichever comes late, we should consider. So at 1, this input is ready. But this will come at 3.5. So 3.5 input is applied. Plus another 1.5 for the mux. So total will be 5 nanoseconds. Total time required will be 5 nanoseconds. This is the first part. It is done. Now the second part. For example, if t equal to 0, we got the answer. If t equal to 1, after 1 nanosecond, you get here inverter will be 0 after 1 nanosecond. So when t equal to 1, it will select this path. So what is the time it requires? 1 nanosecond plus 1.5. You get the input at 2.5 and this input will come at 4.5 because when t equal to 1, this inverter will give you 0. 0 means this will be selected and this will be ready at 4.5 plus another 1.5. Total time required will be 6 nanoseconds. So which one takes more time, 5 nanoseconds or 6 nanoseconds? The total delay will be equal to maximum of 6 comma 5. 6 is the answer. Don't think 7 is the answer by blindly adding all of them. At any given time, only one part will be selected, either 0 wala part or 1 wala part. Okay? Chalo, let's move further. Next question. This is done yesterday. Done. Okay, let's do this question. It is not based on the marks, but it is a good question. We can do it. This question you can take little more time, no problem. Because, but here you must have the patience to read the question properly. If you read the question properly, definitely you will be able to understand line by line, with all the patience. Read the entire question and try to start solving without having any difficulty in the mind. आपका mind पे ये मत रखना, अरे सर ये तो दिक्कत होता है, ज्यादा लंबी क्वेश्चन है, बहुत कॉम्प्लेक्स है, मेरे को पता नहीं है वेंडिंग मशीन का मतलब क्या, ये सभी मत सोचना. केवल और केवल रीड द क्वेश्चन विद कॉन्फिडेंस. डेफिनेटली यू विल बी एबल टू सॉल्व इट, नो डाउट इन इट. सो प्लीज गिव अ ट्राई. गिव अ ट्राई. Last 25 seconds. Okay, I'm up. Now, for the two products are sold from a vending machine which has two push buttons P1 and P2. When the button is pressed, the price of the corresponding product is displayed in a 7 segment display. If no buttons are pressed, zero is displayed, signifying the rupees 2. If only P1 is pressed, 2 is displayed, and P2 is pressed, it is 5. If P1, P2 are pressed, it is error. Okay. Then uh, push button is pressed or not is equivalent to 1 and 0. The segment glowing or not is equivalent to 1 or 0. So this is the segment display. So to display 0 to 5, these are the LEDs to be glow. That is A, B, C, D, E, F, G. You have total 7 LEDs. That's why it is called 7 segment display. Out of them, any one of them or two of them, depending on the input, it will select. It will glow. So let's try P1, P2, P2, P1. Nothing is selected, only P1 selected, only P2 selected, both are selected. You can see if P1 is pressed to 2. P2 is pressed 5. So what is the output here? 0, 2, 5, error. If both nothing is pressed, it is 0. Means all LEDs. If you see what are the LEDs names, you have A, B, C, D, E, F, G. You can neglect the Z, you get 1, 1, 1, 1, 1. All will be 1 except G. Okay, fine, sir, no problem. Next. Hmm. Stupid, all will be 1 F except F and C. F and C will be zeros, remaining all will be ones. Here 5, B and E will be zeros, remaining will be ones. Here E means BC will be zeros, remaining will be ones. Okay, sir, I got it now. Okay. Then here A equal to 1 because it is 1 for all midterms. What about B? You have two midterms now. So P1, P2 bar, P1 bar, P2 bar, P1. So you can take P2 bar common, P1 bar plus P1 is 1, or simply 0, 0, 0, 1. What is the common part? 0. For C, first one and third one. For these two, what is the common is this 0. 0 means here P2 bar, here 0 means P1 bar, because for both of them this 0 is common. Here all of them are ones. Here, three midterms you can write and add, or simply one max term. Max term means this is 0. Write that expression 1 0. 1 0 means for max term 1 happens, 1 means bar, 0 means no bar. Here also, what is F? Only one midterm now. You can write one max term now. So P2 plus P1 bar. What about E, F, G? Only one max term, that is 0 0. 0 0 can be written as P1 plus P2. Now examiner का options क्या? Option G A, G equal to P1 bar plus P2. G is equal to P1 plus P2 ना? गलत है, गलत है. So G equal to P1 plus P2 तो correct है. Out of BD, 1 will be the right answer. He is saying D equal to C plus C. D is equal to 1. C plus E. C is how much? P1 bar plus E equal to P2 bar plus P1. P1 bar plus P1 will give you 1. 1 plus anything is 1. This is correct. So this is the right answer. If you want, you can check E equal to B plus C. Option given by examiner, E equal to B plus C. So E is how much? P2 bar plus P1. What is B plus C? B2 is B is P2 bar, C is P1 bar. It is not same. गलत है, गलत है. So that's the answer. Here vending machine है, सभी चीज तो छोड़ दो यार. Don't worry about what is the meaning of the vending. There is like you see in the airports and all. Na, whenever press the button, you get the and insert the money, you get the product. The same way you have an automatic vending machine. If you press the first button, it will display that particular product price, that is 2 rupees or 5 rupees or both are pressed together. It will say error, nothing is pressed. It will say there is nothing, zero. Okay, chalo. Let's move further. In the same question, there is an extension. Don't read this again. Yes, सभी चीज तो same what we have studied in the previous question. There is few more lines added to understand the remaining part. Read. Same statement, but only extra what are the minimum number of NOT gates and the two input OR gates required to design this logic circuit. Time up. It's not a great difficulty. Already we have done the main part easily. So, yeah. So, what is your A1? A equal to 1, D equal to 1, B equal to P2 bar, C equal to P1 bar, ABCD हो गया, E equal to P2 bar plus P1, F equal to F equal to P2 plus P1 bar, G equal to P2 plus P1. So if you take a P1 and invert, P2 and invert. So P2 bar is B, P1 bar is C. Then P2 bar plus P1. P2 bar plus P1, E. P2 plus P1 bar. F. Okay. Anyway, ADR ones. Then P2 plus P1. It will give you G. I'm just finding a better color to be represented on this board. Okay. So you require 3 OR gates and 2 NOT gates. Thus, this is given as a homework in the last lecture. Now we will do this. Done. Already I have given this as a homework for you. So here, firstly, this is 0. What is your characteristic equation? S bar I naught plus S I1 is my characteristic equation. So S is given with Y. So Y bar X bar plus Yx. That will give you X XOR with Y. Again, you take here S. Okay, for example. So what do you get here? S bar Z bar plus SZ. Okay, X nor here, X nor. Okay, that will give you S X nor with Z. That is nothing but X nor with Y, X nor with Z. This is the answer. This can be written as like this also. X XOR with Y whole bar. First this is done. Again we are done doing XOR with Z whole bar because this is a S XOR with Z whole bar. Actually, this is equal to X XOR Y XOR Z. You can cross check at home if you want. You get the same answer, and that you can check it. But this is given in the options, so this is the right answer. Okay, so whatever you have given, this XNOR with this. Again, this XNOR with this. First, we do this. Bracket is taken to show that associative condition. Then this part is XOR with this. Don't take it as a complement of this one. This is equal to X nor Y, X nor Z. Don't take this as this is wrong. Okay. Some people just take it that the input X nor Y, that's a different case. But this is the right answer. Any of these three are right answers, but this is the one. You can expand and cross check if you have any doubt. Next question. Try. Time out. A combination circuit using 8 by 1 mux is shown in the figure. The minimized expression of Z. Here you have C bar. Okay. Here it is the sum of the min terms. What are they? 0, 1, 2, 6. Right. You can solve by K map first. What is this answer? two pairs are coming. What is this expression is given by A bar B bar plus BC bar plus C bar. You take C bar common here, A bar B bar plus C bar into 1 plus B. 1 plus anything is 1. So what is the answer? A bar B bar plus C bar is the answer. Okay. That's the minimized expression for it. This we have done in the last lecture. It's a very good question. If you are able to solve it, you can give a try. I'm doing more questions rather than theory because that is what you require in your examination. देखो इस पे ट्राई करो. Twenty seconds more. Okay, time up. Little complex. Complex means logical equation. You have a function of f of a, b, c, d now. So they will be all zeros to all ones. So what is your function f is sum of the minterms 0, 1, 3, 4, 8, 9. So 0, 1, 3, 4, 8, 9. बाकी तो zeros. Right? These two 1. I mean, when ABC is 0, 0, 0, what is your output is 1. Here, your output is same as D for 0, 0, 1. Got my point? So for 0, 1, 0, output is inversion of 0, 1. Na? So D bar. Here, it is 0 permanently. 1, 0 permanently. 0 permanently. 0. So 1 D bar, 1D, D bar, 0, 1. 1D. Okay, here small d is the complement of d. So 1 capital D, small d, 1. Okay, W, X, Y, Z. W, X, Y, Z. 1 capital D, small d, 1. As per examiner, this is W X Y Z. Okay. So he has taken only 3 into consideration here. Then what is the output? Originally it is a 4 variable function. Okay. Right. Let's go for the next question. Read this question. Try to answer it. Time up. If we have an 8 input mux can be used to implement any 4 variable function. No. If you have an 8 input mux, you can implement any 3 variable. If you have 3 to 8 demux, actually it is called demotor. There also 3 na 4 variable 9. 64 input mux can be used to build using 9 8 input mux. So आपको 64 by 1 चाहिए तो how many 8 by 1s are required? Divide 64 with 8, you get 8. Divide 8 with 8, you get 1. Total will be 9. So 9 using 9 8 by 1 mux, this is correct. 6 by 64 demux using 3 3, this is also correct actually. 64, how many are required means 9. Actually here it is like a MSQ. Which of the following is not correct is the question. Two of them are not correct. Which of the following statements is not correct? A 8 input mux can be used to implement any 4 variable function. Wrong. 3 to 8 demux can be used to implement any 4 variable function. Both are wrong here. Because you require most appropriate wrong is this one. Okay. This is also wrong, but it is not any. Some functions we can do. If you use inverter, we can make it. So most appropriate wrong, if you want to eliminate the options, only one option to be selected, B. If both are okay, then A and B both are wrong. Okay. Next question. This is done. Now one more question of the switching selection time of the mux. Read this question. Time off. Yeah. A 2 by 1 digital multiplexer having the switching delay of 1 microseconds is connected as shown in the figure. The input mux is tied as shown it as to its own input S. Its own input S. The input which gets selected when S equal to 0 is tied to 1. So when S is equal to 0, you get 1 as the output. When S equal to 1, you get 0 as the output. Okay. The output V naught will be. And the mux is having a switching delay of 1 microseconds. Right. So when S equal to 0, initially, for example, you get a time t equal to 0. Say maybe output is 0. That 0 comes here and the selection line will go here and you get immediately after 1 microsecond, you get 1. After 1 microseconds, you will be getting 1. Now this 1 will come back, right? Then the switch will move to here. When S equal to 1, what is the input? 0 will come to the output after another 1 microsecond. So again, this will become 0 because this is connected back here. So 0 will be selected and 1 will come after another 1 microsecond. And this process will be repeating. So your output will be 0, 1, 0, 1 and so on for 1 microsecond and this for 1 microsecond. Total time period is 2 microseconds, the time period. So the frequency equal to 1 by 2 microseconds. So 0.5 megahertz. Right. Right. So the frequency here will be 0.5 megahertz. So let's continue further. So it will generate a pulse train of frequency 0.5 megahertz. Let's move further to the next question. See, this input is called floating input. When nothing is connected to the gate, this line which is open is floating input. In the TTL logic family, we call transistor transfer logic family, floating input is equal to 1. Okay, I am giving you this information. Use it and try to solve the question. Read. 'Give it a try. 10 seconds. Yeah, the one input is fixed, floating to 1. So 1 plus C is 1. So S2 will be permanently fixed to be 1. S2 permanently fixed to be 1. Okay, no issue. Now see here. You take a K map S2, S1, S0. This is 1, B, A, and 0, 0, 0, 1, 1, 1, 1, 0. Okay. So here this will be permanently 0, 1, 1, 0, 1, 0, 0, 1. So if you see all of them, for firstly S2 0 will not occur because this will never happen because S2 is permanently connected to 1. So बाकी क्या है sir? S2 equal to 1 पे for 4 100 what is the input? 0. For 5 it is 1 6 1 7 it is 0. You can do like this, two different ways. One is you consider this don't care, and write the answer as B bar A plus B A bar. That will give me B XOR A. नहीं है तो you just take only this, no problem. In that case you get S2 B bar A plus S2 B A bar. But S2 equal to 1 now, so that will give you B bar A plus B A bar. B XOR A. Got my point? A XOR B stars. Okay, let's move further. So we start the next part, the marks. Just a minute. So the next circuit we need to discuss is the demultiplexer. So demux is also a combination circuit just like a mux, but it contains the reverse job of the mux. Mux contains many inputs, single output, but the demux contains single input, many output. That is one to many. The input present will be given to any one of the many outputs present by considering the selection input. The selection inputs will decide the input is to be given to the which particular output line. So let's try. This is how it will be. Okay, we have a one single input, and this input is given to 2 power n outputs. Based on the selection inputs, this input is transferred to any of the many output lines available. So let's move further. So demux का काम तो ये है, and yeah. So let's design. Let me show you what you will have in the inside the demux. Right. 1 by 2 and 1 by 4 demux. So one input, two outputs. आउटपुट का नाम दे दो, why not? Okay, so you have one selection input, two selection inputs. Here your required condition is when the selection input is 0 and 1, your output y not y1. When selection input is 0, your input I will be transferred to y naught. When selection input is 1, input will be transferred to I. So the selection input. When selection input is 0, the input I will be transferred to y naught. When the selection input is 1, the input I will be transferred to y. But this is how the design is made. The same way, you have two selection inputs, S1, S0, and one output 0, 0, 0, 1, 1, 0, 1, 1, Y0, Y1, Y2, Y3, four output lines. So the input is transferred to any one of them based on the selection we have done. So the design will be like this: S1, S0. Bus. Okay. So when S1, S0 are 0, 0, 0, 1, 1, 0, 1, 1, you will be getting based on the selection line, the input will be transferred to any one of these four. Okay. So this is how the design is made. This is how you can make a demultiplexer. So you can implement one sort of demux with another sort of demux. Suppose sometimes examiner will ask you how to make implement 1 by 16 demux using 1 by 4. Okay, so if you need 1 by 16 using 1 by 4, take same story. 16 you divide with 4, 4 you divide with 4. Total is 5. But here the order will be reversed because it is 1 to many. There many to 1. So here first 1 multiplexer, output may 4 multiplexer. Total 5 is the answer. The number of multiplexer required. Okay. So mux number of demux required. Mux pay reverse. First many, then last one. Next concept. The next one we need to discuss is a decoder. So decoder is a combinational circuit which contains many inputs and many outputs. It is used for code conversion. Suppose you transfer a data, you don't want other people to be read when you transfer a data. You should encrypt the data and transfer it. At the other end, the receiver must be having a proper decryption to decrypt and understand the data. That is, you are encoding a data. Suppose you want to send your name XYZ. Suppose your name is Ram, RAM. Okay. Maybe R is coded as 5, A is coded as 2, M is coded as 1 by using some coding technique. So we send 5 to 1. At the other end, you should have a receiver. Whenever 5 comes, it should decode as R, and 2 comes, it should decode as A, 1 comes, it should decode as M. Then it will understand the data sent. Other decoders which don't have this information cannot be able to understand. The same way, here what we discussing is very simple. When a decimal number is given, how to convert into binary, and when binary is given, how to convert into decimal. I mean, that kind of binary decoders we are discussing. So encoder is a combination circuit which contains many inputs, many outputs. It is used for code generation, decimal to binary and so on. So say you have many inputs, say as many as 2 power n inputs and n outputs and one enable line. Here it is reverse. Decoder may n inputs, 2 power n outputs. So you can give here a decimal number, you get a binary. Binary you give here, you get decimal, and so on. Hexadecimal to binary, whatever it may be, you design accordingly. Not only binary, you may give some input, it will give its gray code. Accordingly, we design its decoder. Let's see how to make a encoder and decoder. 2 by 4 decoder. It contains 2 inputs, 4 outputs. So the name is AB, and one extra input is there, its name enable, and 4 outputs 0, 1, 2, 3. So here what happens when my input in enable A, B, Y0, Y1, Y2, Y3. When enable is 0, when enable is 0, AB can be anything. When enable is 0, whatever you give in AB doesn't matter, all the output lines are zeros. When enable is 1, when AB is 0, 0, 0, 1, 1, 0, 1, 1, 4 possibilities. What are the outputs you are getting it? 0, 0 mean Y0 will be 1, indicating it is 0. Next Y1 will be 1. Next Y2 will be 1. Next Y3 will be 1. This is what happens when a 2 by 4 decoder, when enable is given, how the output will be based on your Y0, Y1, Y2, Y3. Okay, this is how the what we call decoder is to be operational. So this is how the 2 to 4 decoder works. You can make 1 by 4, 1 by 2 decoder also. It is nothing but just inverter, and extra AND gate is connected with enable. When only one input is there, when that is 0, y naught will be 1, otherwise y1 will be 1. That can be done, but it is. But you see one thing here: the circuit in this 2 to 4 decoder and this DMUX, this DMUX, 1 by 4 DMUX, and this circuit both are same. We mean if you take here the name as S1, S0, and I. So if you replace S1, S0 with AB, enable is replaced with I. 2 to 4 decoder. S1, S0 is replaced with AB. I replaced with enable. Then 1 by 4 DMUX will become 2 to 4 decoder. 1 by 4 DMUX will become 2 to 4 decoder. So the internal structure of decoder and DMUX is same. What is that? Internal structure of same. Internal structure of the decoder and the DMUX both are same. Okay. Okay. So you can also say 2 to 4 decoder, also called as 2 to 4 DMUX. Sir, DMUX is 1 by 4. No, 1 by 4 is normal DMUX. If examiner say 2 by 4 DMUX, it means we are using DMUX as a decoder. So let us see how to implement the functions using the decoder as the 2 by 4 decoder. So half adder, what is sum? Sum of the minterms 1, 2. What is the carry? Sum of the minterms 3. Half subtractor. The difference is sum of minterms 1, 2. Borrow is the sum of minterm 1. Take a 2 by 4 decoder. Make enable equal to 1. Okay. Here, observe when enable is 1, when AB 0, 0, you get output equal to 1. So this is nothing but A bar, B bar, minterm. This is A bar, B ka minterm. This is AB bar ka minterm. This is AB ka minterm. It is indirectly representing, each line is representing a minterm. Suppose if you connect one inverter here, it will represent max term, that is active low output voltage. Here, this is called active high. What is active high, sir? by default all the output lines will be 0. By default all the output lines will be 0. When the particular input happens, it will turn to be 1. This is called active high. You can have active low also. That is, if you take all 4 inverters here, what happens? Or instead of AND gate, you take the NAND gate. What happens then? If you take NAND gates, then what happens? By default, all will be 1. When that particular input comes, it becomes 0 to represent max terms. Now, my example is representing min terms. So, directly add the min terms, your job is done. Sum of the min terms 1, 2, that is, take the OR gate. You get sum and difference. And this is already representing borrow. This is already representing carry. So these two represent half adder, these two represent full adder. Sorry, half subtractor. Just a minute. Let's take one more example. You to use implement 3 to 8 decoder use करके full adder बना. Take a 3 to 8 decoder. Okay. Okay. Sum of the min terms 1 to 4. Carry sum of the min terms 3, 5, 6. Borrow sum of the min terms 3, 5, 6, 7. Take a OR gate. So you can use the same decoder to implement more than one function also. For Mux, it is not possible to implement more than one function, but here you may require extra OR gates, but you can implement more than one function using one particular decoder by using extra OR gates. So what is the meaning of this OR gate? When input is 1, 2, 4, 7, output will be 1. When the input is 3, 5, 6, 7, output will be 1. That's why OR gate is taken. Sum of the min terms. Okay. Same question. Suppose read. Read this question. I'll explain. Just a moment. Okay, chalo. Here it is the same question, but suppose if examiner asks you to implement some function using SOP, it is fine. POS, how to do it? In marks we can convert and do it. Here also we can do it, but directly if POS is to be used. Let's take active high output. That is what we are discussing here. So 3 to 8 people. Okay. Okay. So here you need to implement three input majority gate. What is majority gate means? Out of the three inputs, if majority of the inputs are one, it will output is one. Majority of inputs are zero, you get zero. Majority of inputs means out of the three, at least two inputs must be one. That is given by 0, 1, 1, 1, 0, 1. 1, 1, 0, 1, 1, 1. All these cases, minimum two ones are present. This is given by sum of the minterms 3, 5, 6, 7. If you minimize by K-map, it will give you AB plus BC plus AC. Okay. Okay. Now see. Firstly, you know how to make it using minterms. Sum of the minterms 3, 5, 6, 7. 3, 5, 6, 7. This is SOP. When sum of the midterms 3, 5, 6, 7 is product of max terms 0 to 0, 1 to 4. 0, 1, 2, 4. Product means we should take AND gate, but provided if they are max terms. But here they are representing midterms. If you take an AND gate, what happens? When any one of, generally what happens when any one of them is selected, बाकी three तो zero होता है. When any one of them is zero, AND gate का output हमेशा zero हो जाएगा. Originally क्या होना चाहिए? When the input is 0, 1, 2, 4, my output should be equal to 0. How to convert my output to be 0 means, so I can take bubbled AND gate. Bubbled AND gate mein what happens is minterms are converted into max terms. Or when here by default all zeros are there, it will become all ones. When any one of them is selected, that becomes 1. Inverter will make it 0 and output will make it 0. This is how you can make it with POS. Simple way to represent is take NOR gate. Okay, that is how you can do the function using, implement using SOP. Let's do, active high. Let's design by active low also. Here they are already representing maximums. So here sum of the minterm, product of maximums 0, 1, 2, 4. You directly take an AND gate. It will represent POS. What is this? Active low. where do we use active low, where do we use active high, कैमन कैथोड कौन एनोड, ये सभी चीज तो मैं डिस्कस नहीं कर रहा हूँ because in crash course इतना डिटेल से नहीं दे सकते because that much time we don't have. That will, I mean, in that case we cannot finish the content. But you should understand the meaning. Active low means by default all are ones. When the particular input is activated, you get zero in the output. बाकी तो हमेशा one. Okay. So here you should, for the remaining, for the remaining 3, 5, 6, 7. You can take a bubbled OR gate to convert the max terms into min terms. SOP. That will give you navigate. That's all. So that is about your how to make the function of use output, implement a function using SOP, POS, active high, active low. Simply active high में SOP, OR gate, POS, NOR gate. Active low, SOP, NAND gate, POS, AND gate. That is the gate we should use to implement any function. So the minterms are to be connected. When that particular minterm happens, the output will be 1. Maxterm happens, the output will be 0. Chalo, next. So which of the following can perform more code conversions? This is given in one of the paper 4 to 16 because it can, if you out of the 4 to 16, you can use 4 to 10 for binary to BCD, 4 to 16 binary to octal, or you use in that little part 3 to 8 binary to octal, 4 to 16 is binary to hexa. Like that, 4 to first 10 only you use, remaining 6 you leave it binary to BCD. If you have more size, you can make more conversions. One of the ESE examination they have given. So same story whether to implement one decoder using another decoder. If you have a 4 by 16 decoder, you need a 4 by 16 using 2 by 4. What to do? Divide 16 with 4. 4 with 4. So you should do in the reverse. So total 5. First 1 2 by 4, next 4 2 by 4. Draw the circuit. You just try it as a homework. Here also 256 you divide with 16, 16 will come, 16 you divide with 16, 1, total 17 is the answer. 256 you divide with 8, 32, 32 you divide with 8, 4, 4 you divide with 8, 1, 37 required. You can also say, you can say 37, 3 to 8 or 36, 3 to 8 and 1. See, if when it is not a perfectly one, it means these many inputs are sufficient, these many lines are sufficient, no need to take 8. So you can say 1, 2 by 4 enough. Okay, at this is the order, na? First stage. 1 by 2 can be replaced by inverter. I told this, na? You have inverter. When x equal to 0, what happens? You get here output y equal to 1. When x equal to 1, you get output equal to 1. So this, if you take with a combination of AND gate and enable, this will give you, what is that, A. This is a 1 by 2 decode. When enable is 0, all outputs are zeros. Okay. Without enable, if If you don't need enable input, 1 by 2 decoder and inverter are same. But if you need enable, you should use these extra indicates and this will make 1 by 2 decoder. Because when enable is 1 only, based on A, you get the output equal to 1 or 0. Generally, this is I am saying, whenever 1 by 2 decoder comes, generally in exam, they replace with inverter also, it is sufficient. So this is how you can do the conversions of one decoder to another decoder. That's about your decoder. How much time is left? Okay. We are discussing now encoder. First normal encoder. Then tomorrow we discuss priority encoder and finish this chapter. And tomorrow we will continue with what we call the more all problems on all combinational circuits. Okay, like all PYQs of electrical engineering I'll bring and I will do it. Right. Here, first how this will work, let me explain. When enable is 0, it can be anything, you get all zeros. Or you can say all high impedance state also depends on your requirement of the design. When I0 is 1, your output is 0, 0, 0. When I1 is 1, your output must be 0, 0, 1. 0, 1, 0. So when I2 is 1, it will generate its corresponding code. I4 is 1. You may generate 4 or you may generate its gray code. It is your convenience according to the encoder you are having. 1, 0, 1. 1, 1, 0. And it should generate 1, 1, 1. Here, y2 is equal to sum of, when it is getting 1, 4 cases. What are they? I4, I5, I6, I7. Y1 is getting 1, 2 cases. I2, I3, I6, I7. Y0 you are getting in what are the cases? I1, I3, I4, I7. Okay, so Y0 is 1 for when the inputs are this. So let's design this. See, this is Y2, Y1, Y0, I4, I5, I6, I7, I2, I3, I6, I7, I1, I3, I5, I7. Okay, so here we use enable also. When enable is 1, then only it will work. Or you can use some tri-state buffer. Buffer may, when enable is 1, it will transfer the data. When enable is 0, it will be open circuited or high impedance state. T states are present 0, 1 and high impedance state. That's why it's called tri-state buffer. So you can give any random input and check. For example, your input is, for example, I6 equal to 1. I61, I61, no I6, baki to 0. You get 110. It will work happily. But the problem happens when two inputs are one at a time. Suppose if I5 is also 1, I5 1, you also I5. You get here 1 and 1. OR gate, OR gate may any one of the input is 1, you get output is 1. Na? So this is all ones will come, which is the wrong answer. You understand? So when more than one input is equal to one at a time, this will not work properly. It will work only one input is equal to one at a time, but not more than one. For example, you just assume this as suppose, मैं तो reverse दिया ना figure. Sorry, ऐसा क्यों किया? I'm not. Right. So if suppose any one of the input comes in the input, suppose 8 devices are asking CPU access, and any one particular input is one, this circuit will generate its address here, and CPU will talk to that particular address or communicate to that particular address. Suppose if more than one input is one at a time, it should have some priority and give one of them as an important and that particular address to be generated and communicate with the CPU. But here it fails. If more than one input comes at a time, it is selecting all ones or something wrong, which gives wrong address to be generated. It is to be avoided. That we can avoid with the help of priority encoder, which we discuss tomorrow. Okay. Normal encoder cannot work if more than one input equal to one at a time. We can overcome by priority encoder. In priority encoder, if more than one input equal to one, high priority input will be considered among them. जैसा 1 2 3 4 इनपुट एक ही बार वन हुआ तो किसको ज्यादा प्रायोरिटी हम डिजाइन में दिया तो उसका आउटपुट मिलेगा. हाउ टू गिव हाई प्रायोरिटी टू ए पर्टिकुलर इनपुट etc. We discuss tomorrow class priority encoder and its design. Some part of ROM maybe I will discuss, and PLDs I will give you tomorrow. Then we will do few more questions. Tomorrow your total combinational circuits will be finished. Day after tomorrow we start with the sequential circuits. As I promised you, I'll complete the syllabus maximum by 25th. 1 2 days आगे पीछे हो सकते हैं. Irrespective of your strength, I'll always do it. Today I'm not able to reply you because it is this session only play where I cannot give see your comments today. Okay. Thank you very much, guys. मैं तो signals and systems again and again I'm saying that I'm starting with signals and systems tomorrow. So if you have anyone who are aiming for 2024 GATE, you can inform them to join this course and they can continue their preparation. I'm starting tomorrow at 7 a.m. for the plus subscribed students. अभी तो ऑफर भी चल रहा है, आप 36% तक सेव भी कर सकते हैं इस पे, ठीक है? And yeah, you can join my Telegram channel, Shankar 10, where you can communicate with me better for notes, etc. and all. Thank you very much. See you all. Bye bye.